Rajesh, are you speaking?
Could you please confirm?
No, Rajesh, I couldn't hear you.
What about others?
Now, but it is very low.
It's very low or what? I
Yeah,
have kept
very
the
low.
100.
Hello. Okay. What about others? One second.
Now it is good. Yeah, now it is.
Okay, is it now? Now is it clear?
Yes, Rajesh, now it's good.
Okay, can you able to hear it louder now?
Yes, yes.
Okay, sir. Thank you. Thanks. Now, so we had just discussed about the fork and exec, as well as we had discussed about what is a difference between a compiler and an interpreter, right? And we had even discussed about few commands also. So that is what we did in yesterday's session, right? So today, what we are going to learn today. So if you see the yesterday's stuff, what we have done, we try to even create one small script, actually a very basic script, and we executed it also, right? So there are three methods to execute the script. That's how these are three methods of executing the script, and this is what the script we had written. And always, whenever you write any script, always the script starts with the hash bang slash bin slash bash. If you are returning a bash shell scripting, it should always start the shebang, or it is a magic character we say. So this shebang or magic character will tell the operating system to execute your script under the bash shell. So that's what, and we had even discussed about our shell variables also yesterday, right? So these are the shell variables what we have covered. Right. Okay. So what is our day 7 agenda, or what is the session 7 agenda? Session 7 agenda. So today we are going to look into some of the command sets. So very important. So even though some of the commands many of the people might know about the command, but still I would try to go from the very basic level, right, about the commands. So let us start now. So I have already opened the terminal. Okay. So now suppose I want to display all the files and directories in a present working directory. So I execute the ls command. Ls is going to list out all the files and directories in the present working directory. Now, in Linux or in Unix, every command will always be lowercase. Lowercase. It will not be an uppercase. You cannot have a command like capital S. Like it will always be lowercase. And what else? You have an options and you have an argument. Most of the command has the same syntax, right? This argument, it can be a path also. One of the argument is path, actually. Okay. Now here, whenever you see any commands, actually you have a command, you have an option, you have an argument. This is the syntax basically. You can execute any command without option and argument. Without an option and argument, that command will get executed. But with the help of an option, a user can get an expected output what he requires, actually. That's the reason a lot of option is provided for each and every command. Why those so many options are there for each and every command? Because maybe for some time a user requires certain output which he can achieve by using certain option. That's the reason for every command there are options are available. Okay, and of course after the options you can give an arguments also. So argument might be a file, or it can be a path, or it can be anything. So each and every command in Linux, it has a lot of options as well as arguments also. So this is the syntax you have to follow. And always any command, it might be in Linux, it should always be in a lowercase. It cannot be in uppercase. Okay, I have never come across any command which is in uppercase letter. No, almost all the commands are in the lowercase. Now, so there are so many commands are there in Linux or in Unix, right? We have been doing. See, when the Linux came into the picture, right? Even the commands which were there in a traditional Unix operating system, which was designed by Ken Thompson and Dennis Ritchie, right? Even that Unix machine also had a lot of commands. So, to the true sense, actually, all those commands which were there, the traditional Unix have been carried forward even in Linux also. Even till today, excuse me, even till today we are using those commands actually. So if you see ls command, ls's command is it has not come now, it has been there from 1970s. So when the Unix came to the picture, right, during that time itself ls command was there. So ls will list out all the files and directories in the present working directory. So here you are not giving any path for the ls. So what ls will think that, oh, ls is executing this whatever the present working directory is there, no? So present working directory, where your present working directory? If I execute a command pwd, it will show me the present working directory. Okay. So if I execute ls command, it will list out all the files and directories in the present working directory. All the files and directories in the present working directory. That's what ls does. Okay. Now that's what the information like. But if you execute the ls command, you can see there are, it is showing the files and directories. But the thing is that actually here there's something like a coloring effect is there. Whenever you will see any file, a normal file or a black file, something here you could see this is a black file, right? These files are normal files or these are regular files. So normal files or regular files. So normal files are a regular files are it's like a text file, it's like a notepad or it's like a text file. It is simply a ASCII file. It could be an empty file or it could be non-empty file, whatever might be, but it is a normal file. Wherever you see the blue color, it specifies that that specific file is a directory or it's a folder. So we have something known as a directory. So in Linux, we never say as a folder. Folder term is used in Windows actually, whereas in Linux we use something known as a directory. Directory is something like it's like a folder what we have. Okay, and afterwards you see any green color, any green color, light green color, it is an executable file. So you can make out a file type with the help of a file command. If I say file and specify this hello.c, see, it says that it is a C source file and it's the ASCII text file. So it means that it's a normal file actually. It's a C program, though it's a C program, but it is a normal file only. It is like a text file. Whenever you see any directory, it is in a blue color. If I execute the file command onto B1, it says that this file B1 is a directory. It's not a file, it's a directory. Similarly, if you say file of a.out, it will show that it is an LSB executable. It's like, oh, it's an executable file. Oh, it is some program file. So like that, in Linux actually, you have 7 types of files actually. So sorry, earlier this question used to get asked by many interview, but nowadays I'm not seeing such questions have been asked. So normal file or a regular file, or you can call it a white file, those are all normal files. Directories, okay, and third is nothing but the hard link file, fourth is nothing but the soft link file, fifth is nothing but the pipe file, sixth is nothing but the socket file, and the last is nothing but character device file or block device file. So these are the these are the 7 types of file which you can see on Linux or in Unix. Is there any other 8th or 9th type of file? No, there is no 8th or 9th. Only 7 types of files are there. Okay, normal file, directory, hard link, soft link, pipe file, socket file, character device file, or a block device file. So these are 7 types of files. Now, here By using the executing the file command, you are able to check the information about whether what type of file it is. Or else you can even execute a command ls-capital F and say enter. See, wherever you say slash after the file name, you can consider it as a directory. Wherever you see star, you can consider it as a what? It as an executable file. Normal file, it doesn't have any symbol. For a directory, it always starts with a slash actually. So through ls capital hyphen F also, you can see that what type of file it is. Here, see, I'm using the first option, hyphen capital F option. So whenever you are using any option with a command, right, you should always specify hyphen and specify the option. And here I'm using the hyphen capital F option. Okay, fine. Now you say, Rajesh, okay, this is what I could see that. What any other thing are there? Like what is a pipe file, socket file, and all? Yeah, we will discuss it. Suppose like a pipe file, I want to clear it. So there is a command in Linux known as mk FIFO and say my FIFO. Enter ls. Could you see that there's a file by name my FIFO got created? Yes. Check the file type. What type of file it is? See, it is a named pipe itself. It is a special type of file. It's a named file or it's a pipe file. Okay, fine. Can I execute now ls-capital F? See, it is showing you this pipe symbol. Oh, it means that it's a pipe file like that. Similarly, you have, I see mksock. I don't know if I have a command or not, mksock. So it is not there. Let us see if you have any package with that name, mksock. Not sure if you have a package. So there's a command by name mksock actually. So it's not there. Okay, yum install mksock. There's no package I think with that name, but there is still a command by the name mksock command. So mksock my sock, if you do right, it will create a socket file actually. Sorry guys, I'm not able to show you this, but this is one type of file. This is a socket file. So like that, we have a different types of file. We'll discuss in soon after some time. But let us finish this command first actually. Okay. So now with the help of ls-f also option also, you will be able to understand what type of file it is. But usually what happens, right? People will always check the type of file with the help of a file command. So this is very handy command. So with the help of this file command, we can able to check what type of file it is. Okay. So very helpful in industry. Most of the time, what happen, we all will be using the file command most of the times while working actually, because we need to understand what type of file it is. Many times we will be doing some operation into the file, but that file not be the same as you were thinking. So some immediately what you do, you run a file command onto the file to just to verify what type of file it is. So in that case, file is very handy command actually. Okay. Now, so as I said, right, any command you have, always the command has an option and you have to use the option along with the hyphen. Now, after this, you say, Rajesh, okay, fine, let me clear the screen. Sir, I can do a clear command to clear the screen, or there's a shortcut user, there's a shortcut named Control L. If you execute the Control L, it will clear the screen. If you press Control plus L, it will clear the screen. There are a lot of shortcuts are there. I will keep telling you about the shortcuts later. Once we come to the particular context, that I will keep telling you. So you can note it down all these things, or you can just remember all these shortcuts actually. So when I do a Control L, it will clear the screen. Okay. Now, so if I execute ls command, fine, it will list out all the files and directories which are there in the present directory. But I want more information than what I'm getting. I want some extra information. Then I'll do a ls-capital L. This is one of the options which we call a long listing. We can either call ls-l or sometimes people execute ll command. That also same actually. It will also do a long listing. You could see here that it is showing you some more extra information apart from your file or directory name. Like for example, it is showing you something like a permissions here. Okay. So this is the first column like this, second column, third column, fourth column, fifth column, sixth column, seventh column, eighth column, ninth column. So totally there are 9 columns in your ls-l. LSFNL. Now this we call it as a permission, sir. Can you see for the MK FIFO, the first character is P. Oh, it means it is a pipe file. Okay. Wherever you see directory, can you see it having a D? So you say, Rajesh, I want to only print the directory. So in your present working directory, sir, there's a question will ask. You want to just print the directory, sir. Whatever the directories are there, you print it. How to print it? You say ls-l pipe it to. We are not come on to this command at all like this. See, cap T. See, only directories will be displayed here. See, because all starts with DETD. See, this is a very handy command, right? ls-l pipe it to grep cap T. Right, guys? Are you able to understand?
Yes, Rajesh.
Okay, fine, great. So here what it's happening that with the help of the first character, you will get to know what type of file it is. Similarly, if I say P, oh, it will only display the pipe file. Okay. Similarly, without anything, you will show that, see, these are a normal files. See, it doesn't have anything dash. Means, so I'm grepping with this dash only. Actually, what is this grep? What is this cap? What is this pipe? And all we'll discuss later. I'm just trying to execute some command. Now, when I execute the ls-l command, you will display all the files and directories. Along with that, there are some more extra information like this one, this. What are these things? So these are nothing but these are permissions. Now, if you calculate carefully, there are 10 dashes are there, sir. One dash, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10, like that. Like this, you have some 10 dashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Always the first dash signifies that it will tell you the type of file. The first dash will always represent type of file. If the first dash is a blank, it means that it is a normal file, like this, or normal or executed file. If the first dash is a D, it means it's a directory. If the first dash is P, it means that it is a pipe file. If the first dash is S, it is a socket file. Like that. If the first dash is L, it is a software file. If the first dash is C, it is a character device file. Like that. Character device file. If the first dash is B, it is a block device file. What is it and all we will see later. Don't worry. Block device file. So the first dash will represent what type of file it is. So first dash is over. Remaining there are 9 dashes are there, sir. So this remaining 9 dashes, they are divided into three categories. Like this. Three. So the first 3 dash, after the first dash, the next 3 dash, it represents who is the owner of the file. Okay. To which group he belongs. The next 3 dash is to which group he belongs. And the last dash is about others. So basically, the rest 9 dashes, the rest 9 dashes represents the permissions. Permissions for a file or a directory. In Linux or in Unix, there are 3 permissions are there. One is a read permission. We call it as R shortly, and the value is 4. One is a write. We call it a W, and the value is 2 actually. It is nothing but this is a bit value, okay, and the last is execute permission, and in short because the X, the value is 1. So read is always 4, write is always 2, and execute is always 1. So that's the reason if you do a LSFNC, read write X, read write X, read write X. See, so it means that suppose I created a file. So how to create a file in Linux? There are a lot of methods are there how to create a file, but I would tell you that one of the command to create a file is a touch command. If I say touch Alice and enter LSFL, you could see that the Alice file has been created. It has got some permission. So because Rajesh root has created, root is the owner of that file. So root has a read write permission. Even he has an execute permission. He can forcibly execute it. Okay. For the groups, he has only given a read permission. For the others, he has only given the read permission. So here, this whenever whoever is the creator of the file, right, he will always have a read, write, and execute permission. For the group, he will not give, he will give minimal permission. He will give read permission, he will give execute permission, but he will not give the write permission. Suppose Rajesh is the owner of the file. So I have created the Alice file. So Rajesh has created. Rajesh has the all full access, sir. He has the read permission, he has the write permission, he has the execute permission. So he has every permission. Group. Rajesh wife belong to group category. Group category. So I will not give write permission. Why she has to get into the file and she writes something? I will not allow her to write, right? Yes, but she can read the file, she can execute file, but she don't have a write permission. So for her or for my wife, Rajesh wife, I will give only read permission and execute permission. For others, suppose like Rajesh cousin, far cousin comes, I will not give any permission, read permission. I will not give write permission. Yeah, I will not give read permission, write permission, but I will only give the execute permission. No, he can happily execute my program and see the output. I will not give any permission as a read and write. So there are three categories of permissions provided for each and every type of file in Linux. One is a owner or the user. You can call it the owner or the user, groups, and others. Is it clear, sir? And always in Unix or in Linux, the read permission, the value is always 4, the write permission is 2, and execute is 1. And in short, we call the read as R, write W, and execute for X. So is it clear? You have any doubts? If you don't have any doubts, we'll proceed further. Okay. Now, so now if I execute the ls-l option, this is some permission is provided for each and every file. Now you could say just now I created an Alice file. See, for the Alice file, read write is given, no execute permission. Okay. This 3 is for owner, this 3 is for group, and this 3 is for others. Do you agree with me? This 3 is for owner, not the first dash is for the file tab. Leave out the first dash. Here, this 3, read, write, and dash. This 3 permission is for owner, the person who created the file. This 3 is for group, and this 3 is for others. Now, Linux basically always it provides some default permissions for a file and a directory. Okay. Now, how it provides? What is a way how it provides a permission? Some default permission it provides actually. How it provides a default permission? The Linux provides the default permissions to file or directory, okay, with the help of umask value. Now if you execute the umask command, umask here, could you see that it is showing 0022? So for the root user, the umask value is 0022. So this is a umask value. So based on this umask value, the Linux system or the Linux kernel will provide some default value or default permission to the file and the directory. Always based on this umask value. Okay. Now, for example, just now Rajesh created a file by using touch command. Touch Alice I created. This is a normal file. So whenever you want to create any normal file or a regular file or any black file, you will always create using a touch command, you create a file actually. Now some default permission is given for this file. How the default permission is given? By default, it is provided with the help of the umask value. So here in this case, it is 0022. Forget about the first 0. Forget about first 0. Just consider these 3 digits actually. Forget about this 0. Consider this 022 is a value. So always the formula is that always for the file, always the value is 6666. How it does means it does the minus of 666 with the minus of 666 with this umask value 022. See what will be the answer, sir? What would be the answer? What would be the answer? The answer would be 6 minus 2, 4. 6 minus 2, 4. 6 minus 2, 0, 6. Right? So 66644 is a permission. 6444 is a permission. See, 6 is what? 6 means 4 plus 2 is 6. Oh, read and write. Oh, 6. Okay, fine. So it means that the owner has a read and write permission. Okay, means the owner has a read and write permission. 6 minus 2, 4. 4 is what? Oh, read. So the group has only a read permission. Okay, 6 minus 2, 4. Oh, the others has only a 4 permission. So can you just see it here? ls-l Alice. See, Alice, read and write for the owner. Yes, the first 6. Read and read for the group, that is 4, because you have to map here. 4 means what? It is read permission. 4. And read for the others. See, 4 again 4. 4. So 6, 4, 4. So this is this whole thing full here. It represents 6, 4, 4. Sir. So in alphabetical we write this way, but in numerical we will always represent 6, 4, 4. This first 6 is nothing but it is for the owner or the owner of the file or the user of the file. This 4 represents the group and this 4 represents for the others. So like that it understands. Similarly, for example, for directory, whenever you create a directory, for the directory always it is 777. Now when you create a directory, how it happens that it does a minus of the umask value 022. So how it does? Seven minus 2. What is 7 minus 2? 5. Okay, 5. 7 minus 2, 5. 7 minus 0, 7. Right? Correct, right? So 5. How will get the 5 combination? 4 plus 1, 5. Oh, okay. It means that first 7 means 4 plus 2 plus 7. Oh, it means that the owner, whoever is creating the directory, he has the read permission, he has the write permission, he has the execute permission. So he has all the permission. Okay. For the group, it is 5. Means for the group user, he is having the read permission, he is having execute permission, but he doesn't have the write permission. Okay. For the others also same. He has a group permission, he has a read permission, he has a execute permission. So that's the reason. If I create a directory mkdir John, see, John directory has been created. lsf and ld John. See, can you see that? Read, write, execute for the owner. That is 7. Read and execute for the group. See, 4 plus 1, 5. Read and execute for the other. See, it is matching here. So the umask value for the root is always 0022. For the normal user, the umask value is always 0002. This is the umask value for the normal user. For example, here, yesterday we created some user account, right? cd/home. Who is that fellow? Girish and all we created, right? Let me switch to the Girish user. See, I'm into Girish user. If a Girish user execute the command umask, see, 0002. See, this is the umask value for the normal user. See, normal user like Girish, Suresh, Mahesh, Rajesh, always the umask value will be 0002, whereas for the root user it is 0022. So in interview questions they'll ask you, what is a umask? What is the meaning of umask? So umask is nothing but with the help of a umask only, the Linux system or the Linux kernel will understand how to give a permissions for a file and a directory. Default permissions for a file and a directory. Okay. So for always, whenever you create a directory, it is always 777 minus the umask value of that particular user. You'll get to know about the particular permissions. For a file, whenever you are creating a file, always it should be 666 minus the umask value. Then whatever the value you get, that is not the default permission given for a file. Similarly, for directory, it is 777 minus the umask value. Whatever you get, this is the default permissions given for a directory. Is it clear, sir? Am I clear? If you have any doubts, please let me know now itself. Sir, is it clear? Yes.
Yeah.
Okay. Okay, fine, good. So now, basically, these are the default permission provided for the user and the for any kind of a file. Okay. Generally, basically, we'll always have a file and a directory itself. Rest all other file are also normal file itself. Okay. So now, when I include ls-l, you could see that this first column represents the file type as well as the permission provided for it actually. We'll come to know about the chmod command. I know that some of you might be knowing about the chmod command, but I will come into separately. Chmod command is used to change the permissions of the file or a directory. You can change the file permissions. I'll come to that command very soon after some point of time. Okay. So now the first column is represents the permissions. Second column represents the hard link. How many hard links are there? For a directory, sir, always the hard link is 2. For a normal file, always the hard link is 1. Right. Now, what is this hard link actually? So this is very important. You have to understand very important. Before getting into this hard link or any other type of link, I want to tell you one more information. Like suppose, like for example, if you execute the ls command, I think I lost it. Suddenly it is going. Okay, how it is going, I don't know why it is so slow. Okay, now if I execute the ls command will list out all the functionalities present in directory, right? Now if I execute, there is an option with the name ls-i and say enter. -I means it is a inode number. Every file or every directory will have some inode number. See, for the Alice, this is the inode number. For this file, this is the inode number. For this file, it's an inode number. So what is this inode number basically? What is an inode? So this is many times it used to get asked earlier, but nowadays, as I said, no, if you go for interview, they won't ask it. But it is always better that you should have a knowledge on this actually. So, okay, what is an inode? We will discuss now. Okay, just quickly we'll discuss now. This is a user space. So this is the user space. We know already all these things. User space and this is a kernel space. Good. So here in the kernel space, you know very well the same old story. Kernel will be up and running. This is the kernel. And the user space always user will log in actually. So like some user like root user or Rajesh or Girish, anyone will log in, right? These are the users who will log in the user space, right? Girish will log in. Now, usually what happens there, whenever any user he's creating a file, suppose Girish is sitting and he's creating a file, something like touch Alice. He's creating the file touch Alice, right? He's creating the file touch Alice. He's creating the file. Okay, this file is getting created in his own directory. Fine. So here root also created a file touch Alice. See, this file is getting created. Fine. But what internally happens? What will happen, right? Here, whenever any file is getting created, what the kernel will do? Kernel will allocate a inode for that file Alice. It will allocate a inode for that file Alice. It allocates a inode for that file Alice. What is inode? Inode, it always allocates. Who allocates inode, sir? The kernel will allocate inode for the file. Any type of file it is. If you are creating a directory, if you are creating a normal file, if you are creating a py file, if you are creating a socket file, if you are creating a character-based file, blog, any type of file you create, always the kernel has to allocate a inode for that file. Okay. Now, what is this inode? Inode stands for identification node, or we call it index node actually. So, what this inode contains? It contains this inode in turn. It contains information like who is the owner of the file. Who's the owner of the file? Oh, Girish is the owner of the file because he created this file. Okay. When was the file created? Creation time. When was the file last accessed? When was the file last modified? It means that these three file created, last access, last modified, these are all something like these are timestamps, which are right. It also contains the information about the inode number. Okay, the inode intern will contain inode number also. Okay, fine. It also contains a pointer to the data blocks or addresses of the data blocks. So each and every inode, it contains lot of information, sir. This information, whatever it is contained within inside the inode, we call this information, all this information, we call this as a metadata. Please try to remember this word metadata. So they will ask you in interview, some person, hey, what is a metadata? Sir, you have to say, sir, information about a file which is kept within inside an inode, we call that as a metadata. So whenever any file is created, sir, always an inode has to be allocated. Who will allocate an inode? Your kernel or the operating system will allocate inode for the file. Right? Now, within that inode inside, you have many of the information written. What is those information? So who is the owner of the file? When was the file created? When was the file last modified? When was the file last changed? Okay. What is an inode number? What is a pointer to the data blocks or addresses of the data blocks? It means that, see, now for example, sir, so for example, this is Alice file. This is an empty file, correct? So if you see the file Alice, you could see that it's an empty file. Now what I will do, I'll start typing some text inside a file. So I'm saving some data inside the file. Now this data, this content, whatever I've written, right? This content has to be stored somewhere in a file system, right? So it means that in the file system, there is something like a data blocks. So with this data blocks, what happened, right? Your file contents or your file data will be stored here like this. Actually, the file contents will be stored. So your inode will maintain a pointer to the data blocks or addresses of the data blocks. Like this, it maintains a pointer. So it means that, suppose you say, Rajesh, whenever I'm opening a file via Alice, and whenever I'm opening this file, do you say that we are reading from these data blocks? Yes, we are reading from data blocks. How we are reading the data information about our file in the data blocks? Hey, with the help of an inode, man. Oh, it means that, Rajesh, whenever I'm doing an operation onto the file, is it the operation is happening in the inode? Yes, it is happening in the inode. Now, sir, why this inode is there? This inode because, right? See, whenever you create a file, suppose you're creating a file, touch Alice. What kernel will know, sir? How kernel will know about that file? Kernel doesn't understand the name Alice, right? Kernel cannot do any operation onto the file, right? Kernel can do an operation to the file with the help of a inode itself. Without a inode, kernel doesn't understand any type of file. What kernel will know? So that's the reason whenever you are doing any operation onto the file, whenever you're doing operation onto a file, you're opening a file, you're editing a file, it always does an operation with the help of this inode number. Inode number is always required. It is something like if you go to the college or school, right? When you do, right, you will not be called with your name. You will be called with a number, right? Some attendance list will be there, right? So they'll say roll number 1, roll number 2, roll number 3. You'll say yes sir, yes sir, yes sir, like that, right? Even during your 10th standard or 12th standard, right? When you go to the exam hall, they will ask you for the hall ticket, and in that hall ticket there is some register number is provided. So they will not know your name is Naresh or Mahesh or Suresh, right? They will only know with your roll number. Similarly, each and every file, how the kernel can do an operation onto that file, or how kernel can understand, it can understand with the help of an inode only. Without an inode, the kernel cannot do any operation on the file. So inode has to be there. So whenever any file is created by the user, always an inode is allocated to that file actually. So this inode is attached. It is something like this. See, this is the Alice file. This is the Alice file. Sorry, this is the Alice file. This is something like this. This is the Alice file, and Alice file will always have a link to the inode actually. Something like this. Always it has a link like this. It has a link to this file. Always. So when you say, Rajesh, fine, I got to know what you're saying. When I remove this file, what is happening? I am removing a file, right? You have removed the file, you have deleted the file. What is happening? You say, sir, the link between a file name, that is Alice, and the inode is lost, sir. This is what we call it as a RM-F. That's all. If anyone asks what is RM-F, sir, you are losing the link between the Alice file and its inode number, sir. That's, sir, you are losing. You are actually deleting that link actually. So that is what we are doing with RM-F. Internally, it happens like that. It will deallocate the inode from the Alice file name. When you deallocate, there is no use of this file name. That's why this file will get deleted by the system. Is it clear, sir? Are you able to understand? Right. So similarly, sir, as we know that every file has an inode number. Similarly, even all the user also has an ID. Yesterday we discussed, right? ID. So for the ID, the root user is always 0. For the Girish, there will be some ID 1002 like this. For the Rajesh, it will be 1001. So kernel doesn't understand with the name root or Girish or Mahesh or Rajesh. How it understands with the username? It never understands. It understands only with the help of an ID. Oh, if it is ID 0, oh, it means that he's a super user. Oh, he can do anything in the system. Oh, if he's a Girish, oh, 1002, oh, he's a normal user. He has only little privilege. He cannot do all the operation how the root does. That's how the kernel can differentiate between different user accounts with the help of an ID. Is it clear? Okay. So now, so when we did an ls-i, you saw that it is displaying the inode numbers of each and every file. These are the inode numbers. Clear? Now, if you come back to here about the types of files, okay, you have a normal file, hard directory, hard link, soft link, pipe file, socket file. What are these? Are the 7 types of files. Let us discuss one line information about this. You know very well. So normal file are numbered regular files, right? You can create a file, regular file, with the help of a text command. You can create a file with the name va command. You can even create a file with the help of echo command. You can even create a file with the help of a cat command. You can even create a file by using a greater than symbol. Okay. You can even create a file with the less command. You can even create a file with the help of a more command. So using any of the, even you can create a file with the help of a nano editor or any other editors. So these are the ways through which you can create a normal file. For example, you have an echo command. So I can create a file echo greater than Bob. See? You are creating a Bob file. See? Like this way, you can even create, even with the help of a cat command, also you can create less command, more command, greater command. See, greater command, see, greater command, Ravi. Enter, say less. See, Ravi file is getting created. But usually, what happens? Usually, people use a tux command to create a file, or else they use a vi command or vi editor to create a file. So these are the mostly people use in industry, either touch or the vi command. Okay. So this normal file is nothing but it's a regular file. So you are just plainly creating a file. Okay, this is like a notepad or the text file which we have in Windows actually. Same thing like that. Directory, you know very well how to create a directory. So we use an mkdir to create a directory. Create a directory. So directories are now directory. It has see one more thing, guys. I want to tell you. For example, you created a directory. You created a directory. Okay. Now always if you see directories, suppose if I say John actually, always whoever is the user or root user, you should always have an execute permission. Now, sir, when you how you can do a CD onto the John directory, ls, how you are doing a CD? CD means change the directory. Whenever you do a CD onto the directory should have an execute permission. If the directory doesn't have an execute permission, you cannot do CD onto the directory. Very important. Please try to understand what I'm trying to tell. If the directory, if the owner has only the execute permission, then only he can get inside a directory. Otherwise, he cannot get inside a directory. Okay, fine. So after he getting a directory, if he is creating some more files or some other directories, he should always have a write permission. If he doesn't have a write permission, he cannot create any file or a directory. So you should have a write permission like that. Suppose you sudo su-1 Girish. Girish is enter. Girish will create a directory. Like he will create a directory. Like he'll create a directory by name Giri. So ls-ld Giri. See, he's having all the permissions there actually. Suppose assume that I'll change the permission. Okay, chmod. Okay, I'll give 400 to Giri. He only has a read permission, sir. Can Giri get inside the Giri directory? Permission. He cannot get inside it. Okay, fine. Now just let me change the permission. Chmod 500 to Giri. Okay. Now you see, Giri is having read and execute permission. So now he can execute inside directory. Fine. He can get inside directory. Now he can do CD. Can he create any file? Let's see, sir. Permission. Because he doesn't have an execute permission. So how nice, right? So this permission plays very vital role, right? Guys? So like that way, there are many other important permissions, sir. You have a lot of special permissions are there in Linux. We call it as a ACL, access control list. Some of you might have heard about this access control list. We will discuss after some point of time what is access control list. You have a permission of the sticky bit. Set user ID bit set. Set user ID bit set. Set group ID bit set. These are some kind of a special permission which you use in Linux or in Unix operating system. You'll give some kind of a special permissions for a file or a directory, whatever it may be. Okay, so now that's the reason. So you should have an execute permission to get inside a directory. And inside a directory, if you want to type, you want to create any file or any other subdirectories, you should have a write permission. Without that, you cannot do it. Okay, okay, fine. Now, one more important thing, sir. Like here, I have an ABC directory. John has an ABC directory. Okay. So I'll go inside the directory, ABC directory. When you do ls-a, means ls-a will show you all the files and directories which are hidden or non-hidden, everything. Suppose you want to only show only hidden file. You have to say that l dot. L dot will only show you hidden files. Like for example, let me come out here. Now you could see that there are a lot of files and directories are there. If I do an L dot and enter, you could see that it will only show you hidden file in the hidden directory. Right? You can even create a file, hidden file also. If I set that, I start the dot, I will say that something, Mary, something. So now when you do L dot, can you see that this file is a hidden file now? When you do an ls, you can't see the Mary, but it's a hidden file. Right? Whenever any file or a directory starts with a dot, it's a hidden file. Most of the people, what happen, right, to make sure that their password or anything, right, they don't want to display here over here. They will try to move into as a hidden file or a hidden directory. That's what. Okay. So now when you create any directory, suppose I have a Raju directory, so cd Raju directory, and if I do a l dot or ls-a, can you see that every directory, sir, there are two what do you call, there are two links are there actually. These two links is that, but dot and double dot and dot. That's the reason you could see the, sir, ls-l, you could see that every directory, okay, every directory, it minimum has two links actually. See, it has a two links. See, it has a two links. Why? Because suppose if you go to C1, if you go to the C1, enter, and if you do an ls-a or l dot, see, you could see these two dots. This dot represents, these two are nothing but these are two links actually. So what is this two link means? Suppose you want to go to the parent directory of the C1. Who is a parent directory of the C1? Root is a parent directory. You should always say cd dot double dot and say enter. You will go back to a parent directory. Suppose you are inside the C1, okay, ls-a. So whenever you want to go to its parent directory, always you should do a cd to the dot. Then it will take you to the parent directory. Okay, what is the meaning of one single dot? Single dots means for itself. So when I do a cd dot, see, you're not going anywhere. You are there only. Is it clear, sir? Every directory, sir, in Linux or in Unix, right, it should always have two dots actually. Single dot and double dot. Double dot represents this dot is number. It's a link, you have to say. Link. There are two links are there, sir. One is a two dot link and one is a single dot link. What is this double lock link means? It will mean that it is pointed to your parent directory. The single dot means it is for itself, you have to say. That's the reason whenever you create any directory, I'll create a fresh directory, mkdir, Satya I'll create. So ls, so cd to Satya and say ls-a. See, you will always get these two links, sir, whenever you create any directory. So that's the reason if you do an ls-al, ls-l, Satya, see, ls-ld, Satya. See, it will always have this two link. What is this two link? This two link means, sir, it is a hard link. That is it. Oh, okay. So Rajesh, when I do ls-l, so is the second column everything it represents the hard link? Yes, sir, it is a hard link. It's a hard link. Now here, come back to the file types. Now you say, sir, Rajesh, you are something saying third type is handling. Is this is what you are saying here? Is this the same thing what is written over here? Yes, sir, is the same thing. Okay. Now, Rajesh, tell me, explain me more briefly about this, man. What is handling and softling? I got to know what you're trying to tell, but tell me in detail what exactly. Yes, we will discuss now. What is handling and softling? And this is some people will ask in interview, what is the difference between handling and softling? You have to give minimum some three differences between handling and softling. First, you have to make it clear what is the handling and what is the softling, and then you can give a differences of these three things. Okay, sir. Sir, sounds interesting.
Yeah, yeah, Rajesh.
Okay, 1 second, sir. Okay. Now, okay. So now, what is a hard link? See, basically, hard link is always created for a file, not for a directory. First, I'll write it down the difference, then you will see hard link. Or else I'll write there only. It'll be good actually. Hard link. The first point is that hard link is always created for the files, not for a directory. Whenever you create hard link, new inode is not allocated. Third link, the third part is the hard link cannot be created across partition. Hard link cannot be created across partition. Opposite of hard link is a soft link. Soft link is can be created both for the normal file as well as directory. Second point, whenever you create a soft link, a new inode is always allocated. Here, whereas in case of hard link, the new inode is not allocated. The same inode is used, like that you have to check. The new inode is not allocated. The same inode is used. Same inode is used. And third point is that soft link can be created across partitions. Whereas a hard link, you cannot create a hard link across partition. So these are the three differences you have to say minimum for a hard link and a soft link. Okay. So now, so just we'll see how exactly we can practically show this. So I have already have Alice and Bob and everything. Let me remove this file, Alice and Bob and John, whatever. So let me remove this file. So I remove the file. Suppose assume that I'll create a file Alice. So I'll say vi Alice. I'll open the file. I'll just type some text inside the file. So this is my file. I have an Alice file. Now I want to create a hard link for the file Alice. Hard link is nothing but it is another copy of a same file. So it means that it's another copy of a same file. So I want to create a hard link. So I'll say I'll use a command ln. Ln is not right. Ln is the command used to create a hard link. I'll say Alice. And what is the hard link file name you want to create? Bob, sir. Enter. So I'll say ls. Can you see that? Bob file is got created. Bob file is a hard link for the Alice file. It means that Alice file, what are the Alice file contain? Even the Bob file also contain. Or you can say Bob is another copy of a same file. Okay. So if you see cat of Alice, so you will see that I have written this two line. Can you see a cat of Bob? It's the same line. Okay, fine. That is, if I open the Alice file, I'll try to add some more text inside the file and save that file. Will the changes occurs in Alice also? Yes, sir. The changes will occur in Alice also. So wherever you do, it will be same. Now you saw at the time you do ls-i Alice. See, it will show the inode number. Let us see the inode number for the Bob. See, the inode numbers are same. It means that both the files are pointing to the same inode like this. So this is the Alice file, this is the Bob file, and this is the inode. Correct, sir? This is the inode number. Right? Both this file are pointing to the same inode like this. If any one file is doing any one operation out of the file, it is reflected into other file also. It is just another name of the same file. This is inode, this is Alice, and this is Bob, right? Alice and Bob. Clear, sir? So usually what happens, right? Many times what happens in industry, right? People will tend to keep a hard link. Who knows? You will remove the original file. You might remove this original file Alice itself. Still the Bob exists, right? Because still Bob is pointing to the same inode, right? So you know that if there is no hard link, if I remove the Alice file, you are losing the link also. It means that you are losing the data also. So sometimes what happens, people have to keep that the file should not be removed. So they will tend to keep the hard link for that file with some other location within that same partition. They will try to keep it so that if mistakenly somebody is removing the original file also, still the Bob will exist like that. Right? So you can either use ls-i to display the inode number, or else there is one more command, the stat command is there, stat Alice. This is also very important command. Stat will give a statistical information about that file. Apart from the inode number, could you see that this is the same inode number it is displaying, right? Apart from the inode number, there are so many other information also there. So this is nothing but it is a file name is Alice, okay? The size of the file is 31 bytes, okay? The IO block device is 406 bytes, and it is a regular file. And you could see that what is the device identifier and how many number of links it has. Oh, it has 2 links, okay? What is the access permission, modified permission, change permission? These are all the different timestamp with which it has actually. And user ID, group ID. Who created this file? Oh, Alice root created the file. So root user ID is 0, group ID is 0. Similarly, suppose like same thing if I go to stat Bob. See, Bob also point to the same inode only, right? See, the inode numbers are same over here. Similarly, if you switch to the Girish, and Girish creates a file by name Giri something. So file is I'm sorry, then I think this Giri directory is there. So we set up Giri. Let's see. If I execute a stat command on Giri, see, it will give static information. It will show what is the inode number. See, 10003 is the user ID for the Giri section. Group ID is also same. And these are the 3 timestamps. And the file is 0. It's identified, it's showing as a 0. Block size is 0. IO block is 4096 bytes. What is IO block and all? We'll discuss later on in the file system. And this is a regular file type. So these are some statistical information which is stored by the stat command. Now somebody is very intelligent. They might ask, Rajesh, you said something about file creation and all. It is the inode content, right? And which we call the metadata. If stat is displaying, the stat command is displaying the metadata information about the file from the inode. Yes, these are the metadata information about that file. Okay. So stat command is the stat is actually reading the inode information. Yes, it is reading the inode information. How it is reading? Don't worry about all this. So it internally calling some API, some system call to read the data from the inode itself. Internal means in the kernel space, it is called. Okay. So now coming back to our hard link and the soft link actually. So I have created the Alice file. Oh, sorry, I have created a Bob file. Here I'm exiting out from the grid. I have created a Bob file. Bob file is a hard link to the Alice file. Now you could see that as soon as I created a hard link, you could see that for Alice, first earlier it was 1, now it has increased to 2. It means that you have created one more link, one more hard link you have created, one more pointer you have created. That's the reason it will tend to increase from 1 to 2. Okay, suppose if I remove original file, I'll remove rm-f Alice. You're forcibly removing the file. Rm is remove, f means forcibly remove the file Alice, and say enter. See, and say ls. Still you are able to have a Bob file. Still you can see the data of the file. So this is what a little advantage what you will get when you are creating hard link for a file. Okay. You cannot create a hard link for a directory. Raju is a directory. So I'll say ln, Raju is a directory, and I'll create a Ravi as a hard link. Hard link cannot be allowed for a directory. So that's the second point. Hard link cannot be created. Is always created for the file, not for a directory. Whenever a hard link is created, new inode is not allocated. Yeah, that we saw. The same inode is used, right? Whereas in Alice and Bob, you saw it, the same inode was used actually, because both the files are point to the same inode. So no new inode is not allocated. The same inode is used. And hard link cannot be created across partition. See, right now you are actually working as a part of the, you are actually working under the root or on the slash. So slash is having a different partition like this. If I do it right, so this is what nothing but the slash partition, sir. 10 GB slash partition. If you say E2 label slash dev xvda2, it says that it is a magic, it's a slash partition actually. It contains XFS partition, it is a slash partition. So, or if I execute a command, or if I execute df-h, display-h, can you see slash dev sda2, it is actually under the slash partition. So I don't have any separate partition over here, otherwise I would have shown you. So suppose I have one slash partition, one more slash USR is the partition there. If there is any one file in the slash partition and you want to create a hard link for the file under the slash USR partition, it is not allowed. So it cannot create a hard link across the partition. That is not allowed when it comes to hard link. Okay. Now opposite of hard link is a soft link, sir. Soft link can be created both for an overflow as a directory. Soft link can be created as across partition. But when you create a soft link, a new inode is allocated for the soft link. The same inode will not be used. As in hard link, right? The same inode is used, right? Whereas here in this case, the same inode will not be used. A new inode will be allocated for the soft link file. Now let us see how to create a soft link file. Let me remove that BOB file also. Okay. So I'll create a file Alice. Same thing, Alice. So I'll try to write like this. So these are two lines in the file Alice. I'll save this file. Now I want to create a soft link. Soft link is something like a shortcut what we have in Windows. Suppose you know that Rajesh, I have a D drive. Inside a D drive, I have one folder. Inside that folder, I have one movie. Every day I want to watch that movie. So why you want to navigate to that path or go to the D drive, go to that folder, right? Can to create a shortcut in your desktop. So many times we create a shortcut, right? The shortcut is same thing as in Linux. What we call is a soft link actually. So now Alice file is there. Alice file I want to create a soft link now. I'll say ln -s is the option to create a soft link. I'll say Alice and I'll say Bob. See, when you do ls-l, can you see that Bob file is created? See, Bob is created, but Bob is something, it is looking in a light blue color, right? But Bob is a pointer to the Alice file. Oh, it's a pointer to the Alice file. Okay. So when you do an ls, you could see that Bob file has been created. So can I run a file command onto the Bob and check what is it? Oh, it's a symbolic link to the Alice file. Oh, it is a pointer to the Alice file. So here, if you do ls-l, wherever you see L, it means that it is a soft link file. For example, if you go to /usr bin, you see that a lot of commands are there, right? Could you even see that these commands are there in a light blue color? When you do ls-l, see, there are so many, see, this L stands for it is a soft link. See, this is actually a pointer to the hostname command. Oh, this is pointed to this command, df-3. See, these are all soft link files actually. Soft link is not, but it's like a pointer. Now coming back here, you have a Bob file. You will say, Rajesh, okay, I'll do one thing, sir. I'll open the Bob file itself. Okay, I'll open the Bob file. So Bob is a soft link file. So now I will try to add some more text. Same thing. Will it update in Alice also? Yes, it will update, sir. Because Bob is not, but it's a pointer to the Alice file. Okay. Shall I check the inode number? Okay, this is the inode number for Alice. Okay. What is the inode number for the Bob? See, the inode numbers are different here. That's what I said. The second point here is that whenever you create a soft link, a new inode is allocated for the soft link. The same inode is not used. And soft link can be created across partition. That's what I said, that if you have a slash partition and you have a /usr partition, if there is any file under the slash partition. If you want to create a soft link of that file under the /var or /user partition, you can create. Soft link will be allowed to be created. Okay, sir. So now you are comfortable to say anybody, right? What is the soft link hard link? Yeah, Rajesh, where the soft link is used? Okay, fine, I understood. But where it is used? Okay, I will discuss about the usage of this. Maybe after some point of time, you will get to know the usage. It is very, very important that soft link will be where it's used. How exactly effectively used, we will see later. Okay, but soft link is like a shortcut, we say. But in Linux, how effectively we can use, I'll come up with some few examples where I will show you at that time. Like this is why the soft link files are required. Like that, I will give you the scenario based, then you will understand. Okay, this is why the soft links are used. Okay, so that we will come into that later after some point of time. So now what happened, right? Here, when you do an ls-l, you could see that Bob is actually pointing to the Alice file. Earlier, very long back earlier, they used to call that actually, Rajesh, in the ls-l, okay, this first column will represents the permission. Okay, the second column represents the hard link or file. Third column represents the user ID. Fourth column represents the group ID. Fifth column will represent the file size. Okay, file size. Okay, it will be the size of that file. What is the size of the file? So that will is represented by the 1, 2, 3, 4, fifth column, right? File size. But you could see the Bob actually. The size of the Bob is 5. It is not 5 characters, sir. If you see cat of file or cat of Bob, do you think that the 5 characters is more than 5 characters, right? There are more other 31, 32 characters are there, but it is showing is 5 itself. Now, what is it actually? In some interview, there was for some few people. You have to say, sir, a Bob also has an inode, but inode in turn will contain the number of character of the file which is pointing. See, ALICE, it's 5 characters. So this 5 characters are what? It will be saved actually. Suppose you have a texture, Abhinav. Okay, when I say ls-l, Arav, Abhinava. I to create, right? ln-s. Hey, where are you now? Okay, ln-s. Sorry, ulta I have to do. Okay, this Arav, okay, it is having 8 characters, sir. 1, 2, 3, 4, 5, 6, 7, 8. See, that 8 characters. It means that this Arav will always keep the string length of that file under the inode number. That's what is showing 8 here. This is how you have to answer. So, sir, it means that what exactly it happens means actually whenever you are doing any operation onto the file to the Bob, actually you are doing an operation onto the Alice file. Because this Alice in the inode and the inode of the Bob, it contains a pointer to the Alice only. Similarly, in the Arav inode, if you read the Arav information of inode, it has a point to the Abhinav file only. So it means that when you are doing any operation onto this file, literally you're actually doing an operation onto this file only. You're not doing it to the RF file. It's just like a pointer, sir. That's all. It is not. It is a file, but it's like a pointer. It is like a pointer actually. Suppose you remove original file, like here, if I remove the Alice itself, you remove. Bob is actually pointing to Alice. Now it is pointing to Alice. This original file itself is removed now. Now what will happen? See, Bob is actually pointing to Alice file, but the Alice file itself is removed. Oh, it is pointing to some file, but that file itself is not there. It means that this is something. It looks like it's a dangling pointer. It is pointing to some address, but that address is not existed. That we call a dangling pointer. So this is what in interview for the developer they'll ask. What is a dangling pointer? Sir, a dangling pointer is a pointer where it points to some particular address, but that particular address doesn't exist at all. So it leads to a dangling pointer like that. Dangling, D-A-N-G-L-E, dangling pointer. This is what dangling pointer. Dangling pointer is like this. Sir, is it clear? Are you clear till here?
Yeah,
Any
yeah,
doubts, sir?
Rajesh, this is fine.
Sir, any doubts you are getting, or you are understanding everything at first shot?
This hard link is very similar to copy, right, Rajesh?
Same thing like copy only, yeah. Copy only. But
in-
what happened if you're copying a file, right? For the copied file, right? For the new, you will get an inode number, a new inode number.
Right. Okay. Got it.
Yeah. Whereas for hard link, there's no new inode. The same inode is used actually. Okay. Okay. Okay, fine. So now you have lost that link. It means that you lost the file. You open the file bar. Yeah, it doesn't do no. It will try to point to the Alice. It looks like it's a new file, right? But actually, it has lost that link itself. Actually, that soft link itself, it has lost because you have removed the original file itself. So that's how it is. Now that's the third and the fourth type of file. Okay, the fifth type of file is a pipe file. Pipe file is it is like a FIFO file. Now, before getting the pipe file, sir, let me explain you some more thing about what is a pipe in Linux. Actually, very important. We have to now get into understanding about what's a pipe actually. Now, so basically, before the pipe, before the pipe, I will try to explain about what are the redirection operators. Then you will understand the pipe. We are going the reverse order. Redirection operator. So once we come into the redirection operator, once we complete it, then we will go with the pipe. Once the pipe is completed, then we'll go with this type of file. See, that's how it is. Because to make you understand this, I need to explain a few more things like this. What is a redirection operator? In Linux, actually, you have a redirection operators like this: lesser than sign, greater than sign, double greater than sign, double less than sign. These are some of the redirection operators what we use in Linux. Also, we have sometimes people have seen like this. Actually. This symbol also people have seen. What is it? We see later. We will see in some time now. Now, before that, let me explain you something like what are the data channels. Now, you basically in any operating system it might be Windows or it might be Linux, Unix, Mac OS, anything. There are some data channels are there, sir. What are those data channels? Data channels are the channels where you communicate with your system. See, I am communicating with the Linux machine with the help of this terminal. This terminal will act like a data channel. So with this help of this terminal, I'm able to execute any commands, right? So how I'm actually communicating with the kernel or with the system with the help of a terminal. Okay, terminal is something like a virtually you are connecting with a machine with the help of some terminal actually. This terminal, we call it as a data channel actually. Every data channel, it provides some, some standards. The standard, what are the standard means? It provides a data channel like standard input, standard output, and standard error. Yeah, these are the three data channels where each and every terminal provides to the user actually. What is the standard input? Standard input is nothing but your keyboard, right? Because I'm pressing here. Suppose I say here, you say Rajesh, execute the date command or ls command. What I'll do, I'll say ls. How I'm giving input to the terminal through the keyboard only, So keyboard will act as a standard input. So apart from keyboard, is there any other inputs are there? Input devices are there? Yeah, it could be there, but right now I'm using the keyboard, or I can even use a keypad also, right? So keypad or keyboard, anything. So standard input is nothing but your keyboard. Always the standard input, the value is always 0. Here's a standard output. Suppose I execute this ls command, I'll say enter. You are getting output to the screen or the monitor, right? This is the monitor you are seeing, right? This is my monitor. This is my screen. I'm seeing the output. Similarly, in the Windows, this is my monitor, sir. This is the desktop. This is the monitor where I could see all kind of an output, whatever I'm getting it. What is that output? That we call as a standard output, sir. That we call as a standard output. The standard output is not what your screen or the terminal. Sir, in Linux, what we call as a terminal, sir? What is the command to check the terminal name? Yesterday we executed this command, right? What is the command, sir? To check the terminal, in which terminal you are working.
TTY.
Yeah. So TTY means it's a terminal. So what is this terminal actually? Sir, it's a serial terminal. It's a serial device terminal. It's a serial terminal. This screen or the terminal or the monitor, we call it as a standard output, sir. Standard output, and always the value is always 1. Very careful, sir. Please listen very carefully what I'm saying. This is very important. And standard error. What is a standard error? Suppose if I execute some command, this command doesn't exist. So you are getting an error in the screen only, right? Or in the monitor only, right? Or into the standard output only, right? So the error is getting into standard screen. So this we call as a standard error. Even error also we are getting into the screen only, because user should know what kind of error you are getting. So here the standard error is also screen or terminal or the monitor. And the value is always 2. So standard input is for a 0, standard output as an error, sorry, standard output as a 1, and standard error is equal to 2. 0, 1, and 2. Like how we have for the file, no? 4, 2, 1, something similar like that. You have a 0, 1, and 2. Standard input, standard output, and standard error. Okay, fine. Now you say, fine, that is good, sir. Now you say, Rajesh, I'm executing the ls command, fine. I'm getting the output to the screen or to the monitor or to the standard output. I don't want to get this output to the screen or the monitor. I want to redirect to some other file. So then you know very well that I use a ls command greater than specify some file name like file1. See, instead of the output coming to the screen, you are redirecting that output to the file by name file1. So what Linux will do that, oh, you don't want this output to come to the standard output. Oh, you don't want the output to come into the one value, that is standard output. You should not get into this one. Oh, you want to redirect to some file name. So file name. So what Linux will do that, it will check in a presume directory. Is there any file one, the file with the name file1? No, there is no. It will create that file, and then what are the output of the ls command is there, that will be redirect to the file1. So if I execute the cat of file1, see, it will have the output of the entire ls command. Okay, fine. Now let me execute the same. Let me execute the date command now by redirecting it to the same file1. So now what happened, right? Now the command, now the kernel will check, is there any file1? Oh, already file1 exists, sir. Yes, there's a file1. But this file1 has an output of the ls command. No problem, right? Let me rewrite the whole output with the help of a date command. So here you're doing a date redirect to the file1. Okay, now if you open the file1, cat of file1, you could see that the date output is there. But what about the ls output? That is gone when it is overwritten it. Ah, okay, fine. Fine. It means that whatever the content previously it has, this has overwritten. But some people say, no, Rajesh, I don't want to overwrite it. I want to just append the data to the end of the file. No problem, sir. You execute the command, who am I, something. Double greater than you have to use to append don't overwrite the data or don't overwrite the existing content of the file. Append whatever output, you have to use a double greater than. Now you could see cat of file1. Earlier the date output was there. Now the who am I output is also there. So these symbols you have seen in many times you have been using in your at your work also. So this we call it as a redirection operator. What we call as a redirection operator. Similarly, for example, you have a command by name wc. Wc called as a word count. Wc command called as a word count actually. So this is very helpful. Many people use this command in a day-to-day activity. So what this command does, suppose if I say sir, wc and say enter. So here wc command is asking input from user. I'll say hi, how are you? Bye. And I'll say control D. See, it will show me that there are 3 lines are there. There are 5 words. 1, 2, 3, 4, 5. 5 words. And there are totally 19 characters including the space also. So word count will give you the number of lines, number of words, and number of characters. Very important. Right? Now you will say, Rajesh, I want to get the number of line, number of words, number of characters of /etc/passbody file. So what will say, wc lesser than cat etc/passbody. What less than means that instead of getting an input, see here when I execute a wc enter, it is asking an input from the user. I gave the input in through my keyboard. I said, hi, how are you? Bye. Then I did control D. Then I got the output. But here what happened, right? WC is getting an input from the etc password file itself. So this lesser sign means it is an input. So here you could see that standard input is not but 0. Oh, you have to get from the keyboard. But here WC is not getting it from the keyboard. It is actually getting input from the file. So with the help of a lesser than sign, it is actually getting input from the file, not from the keyboard. So when you execute this command, see, it will show that there are 27 lines, 49 words, 1343 characters including the spaces. So this will show you the number of line of word, characters, and everything. Some people say, Rajesh, I want only number of lines like this. I want only the number of lines. Oh, only 27. So many times people will see, hey, how many lines are there in the file, man? How to check it? I always say wc-l and specify the file name. You will get the number of lines, right? So this is what one common thing people ask: how to check how many number of lines are there in a file? wc-l. Okay. Same thing. wc-t. How many number of characters are there? How many number of words are there? So here, lesser than sign means input redirection. These are not but output redirection. Okay. Okay, fine, sir. Now you say that, okay, fine, Rajesh, I got this point, everything fine. Now assume that I'm getting some error. Suppose instead of date, I'll mention as a data. What is that? Command not found. Okay, fine. Rajesh, command not found. This is an error. But you say that, Rajesh, I don't want to get this output, this error output to the standard screen one. I don't want to get it. I want to redirect this error output to some error file. Okay, so I'll check data to greater than error file, error underscore file. See, the output will not come to the screen because this is an error. So their error will be redirect to an error file. See, when I do a cat of error file, it has the error output. So whatever you had, no command not found. So that error has been. So here you have to use two greater than, because here you know that explicitly that there is an error. You cannot use a single greater than. Single greater than means it's a standard output. See, when I execute ls command, redirect to file 1, or when I execute ls, redirect it to, or det, redirect to file 1. What you're doing, you are redirecting the actual output to the screen, or to the file. So Rajesh, is it the same as like this? Yes, sir, it is the same only. So here, what is 1? 1 is not but standard output. So if you are not mentioning 1 also, you are only mentioning greater than, it means that it is 1 only. Oh, instead of getting the output to the screen or the monitor, you are redirecting the output to a file. Okay. Oh, instead of similarly like that, if I execute who am I, double greater than file 1, you are doing the slide. What it means? It means that this one is like this, 1 double greater than like this. By default, it is always 1 only. But when you know that I'm redirecting an error to a file, I'm error to the file like LTT, this is a command not found. When you're doing it, you have to explicitly mention to this file. Otherwise, it doesn't understand. Sometimes what happened, that some people say that, Rajesh, I don't want to get this error to the file or someone. Why I have to unnecessarily keep this error to the file? I don't want to keep it. I don't want the error to come to the screen at all. So in that case, people use this like this, to greater than /dev/null. See, the error will not come to the screen. There is no, it will not create any /null file. This file is already existing, special character device file. You are nullifying the effect. You're not making the error to come to the screen at all. You have to nullify the effect. In many of the script, you might see this to greater than /null. You might have seen it. So the error, you're not making it to come to the screen. You are redirecting to the null file. Null is a special character device file. /null. See, it's a special character device file. See, character device file. See, it is a special character device file. It will nullify the effect. It will not make the output to come to screen. Rajesh, can I redirect? If I execute ls command, fine. Can I redirect the ls output to the /dev null file? Yes, sir, you can redirect it. No problem. It means that you don't want the output of ls also to come to the screen. You want to just redirect the output to some null file. So you can do that. Sir, am I clear till here?
Yes, Raj.
Okay. So here, what you're doing, right? Here you are trying to redirect the way user required. If he needs a file, proper file to be output to be read to a file, he use a greater than or double greater than. If you want to redirect any error which is coming to the screen, I don't want the error to come to the screen, man. I want to redirect that error to a file, actually, error file. See, for example, I'll just show you. For example, if I use a find command, right now I'm not just watch or just see what I'm doing, but I will explain about find command later. If I say find slash hyphen iname. Okay, this is coming fine. But if I do the find command slash hyphen from, you could see that you're getting an error. Find command is actually getting an error. No file directory. This is actually error actually. Find command is finding the file which is having the permission 77. It is finding all the files which is having the permission 77. So it is still finding it out. Okay, fine. But you could see that Rajesh, while finding it out, I'm getting almost a lot of errors. I'm getting, man. I don't want to get the error output to the screen. I want to redirect to some error file or I want to nullify it. So how we will do? Same command. If there is any error, redirect that error to a /null file. Now the actual output only will come to the screen. All the error will get nullified. Or else you say, no, Rajesh, I want to even see the error also. No problem. You say you create your own file, error file. The actual output will come to the screen. The error will redirect to error file. See, error file. Can you see here? Error file. See? If I execute cat of error file, see? Can you see these are the errors, right? Find command as one out, right? Like this way, you can use this to greater than. If you don't want any kind of file to be created, then you can do a to greater than /null. Okay, clear? Okay. Suppose somebody says that, okay, fine, I will say the same thing. Rajesh, I want to run the same find command. I want to get the actual output to an output file, like something like this. And I want to get any kind of error into the error file. Running this command, the actual output is go to the output file. What are the error is there? Whatever find command is finding error, that error is getting into this error file. So can you see? There's a file by name output file. See? Cat of output. Oh, it has an output file. Cat of this error file. It has an error file. So it means that you are not getting any output to screen. You are redirecting all the output to an output file, and if there is any error, that error you are ready to error file. Some people are very clever. They'll say, Rajesh, okay, no problem. I understood this one. You say that, Rajesh, I want the output to the output file. Output file, okay, output file. But even whatever error is coming, I want to even get the error to the output file itself. Even the find is finding error. Now, if you run this command, what will happen? See, the error only will come, but the actual output has gone to the output file. But you say, no, I don't want to get this error to the screen. I want to get the error also into the output file only. I want to see. Then you do one thing, to like this, to greater than &1 like this. See, now you could see that what are the error you are getting, what are the actual output you are getting, that output is read to the output file. Even the error also you are redirecting the output file only. See, output file. See, you are getting the error as well as you are getting the actual output. Everything you are redirecting the same file. Sometimes it is a requirement. Maybe there's some requirement. They'll say, oh, even error also I want to get man to the file only. Then you use this method. So is it clear, sir? You understood why I'm using this 2? You understood because 2 stands for standard error. Always the value is 2, or with that, always the error will be redirected to the standard, to this standard, to this value 2. Now, if some of you keenly ask me, or if you're really interested, Rajesh, what is 0, 1, 2, man? I understood what you're saying is right. 0, 1, 2 is some value. 0 stands for standard input, 1 stands for standard output, and 2 stands for standard error. I understood. Oh, these are like 3 data channels. Okay. So we are communicating with the system. As a user, I'm sitting in front of a system and communicating to the system or to the Linux machine with the help of this terminal. So this terminal has its, does this terminal has its 0, 1, 2? Oh, yes, sir, it has its 0, 1, 2. Okay, fine. Where it has it, or what are the 0, 1, 2, Rajesh? If you ask me keenly, sir, I'll say 0, 1, 2 are file descriptors. Okay, file descriptors. Okay, sir, every process has an array of 255 file descriptors. You know, on the first day of class, I told that what is a process. Whenever your kernel or the operating system, it creates a process, right? A process is what it is, a running instance of a program in memory, we call it a process. A running instance of a program in memory, we call it as a process, or a program in execution, we call it as a process. So for every task the operating system is executing, it can execute with the help of a process. Without a process, the operating system or the kernel cannot execute any task. There has to be a process. And as I said, right, each and every, this is like a process. The process will always be running in a system. This process has the information. I told you, right? It has a text segment, it has a data segment, it has a stack segment, right? These are the content of each. It has a heap segment. It has some environment variables, env environment variables. Like that, there are many informations are there within the processor. Even this same processor, this we call as a processor. This we call as a process. The same process will also have an information about the array of 255 file descriptors. In short, sir, in short, two array of 255 file descriptors. In short, we call something like this FD 255. Okay, Rajesh, it means that in the 255 array, 0, 1, 2 are always reserved. Huh? Oh, yes, sir. 0, 1, 2 is always reserved for this process. 0 stands for standard output, 1 stands for standard output, and 2 stands for. Okay, fine. What about 3, 4, 5, 6, 7, 8, up to blah 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 up to 255? These are not free descriptors. These are available descriptors. Okay, fine. Rajesh, now I understood 0, 1, 2. Okay, fine. Rajesh, assume that. Okay, fine. I got your point. Now, what you're saying, nicely understood. Now, Rajesh, there's an Alice file, is there? You're creating an Alice file. I'll open this Alice file. I'm doing some operation onto this file. Does your process will use some file descriptor to communicate with that file? Yes, sir. What is the next level? Oh, 3, sir. 3 is a file descriptor which it uses to communicate with that Alice file. Oh, okay, fine. Rajesh, if the Bob is at the same time, if Bob is open and user is doing some operation on the Bob, how does process will communicate with that Bob? Hey, it communicates with the help of a fourth descriptor. Then next file, 5th descriptor, 6th, 7th. Oh my God! It means that every process, whenever it communicating with any file or it is doing any operation onto the any file, it always uses the file descriptor. Right, sir? At a time, whenever it means that a single process it is opening these 3 files, it means is it using this file descriptor to communicate each and every file? Correct, sir. Okay. But you said something that Rajesh should communicate the inode number. Yes, sir. This file descriptor is there, right? For here, the Alice file descriptor is what? Alice file descriptor is 3. Okay, 3 file descriptor is used. The 4th is the file descriptor 4. So 5 is for the John. Okay. This file descriptor actually it'll be communicating to the inode number. It'll be communicating with that file's inode number. With this inode number. Sorry. This inode number. Beautiful, man. This is how the communication is happening. Is it clear, sir? I don't want to go in detail more, but this is what in a very high level I'm explaining you. Clear?
Yeah, it's right. Yeah.
So how beautifully this concept comes, right? See how the process coming, how inode is coming, how exactly user is actually doing operation. Till now you don't know. You are simply opening a file, doing an operation, but internally how it happens? It happens with the help of a file descriptor. Internally that file descriptor will have a pointer to inode, and from the inode it will point to the disk where exactly the file content is stored in the disk actually. So everywhere what happened that your kernel is coming to the picture. So kernel is the main boss. He is actually doing an operation, all operation, whatever user is working, right? He is doing on behalf of you only. So I'm opening a file, I'm doing some operation file, I'm double clicking on this icon, I'm going to insert this folder, blah, blah. You're doing many operations, but who is actually doing? Your operating system or the kernel itself is doing. That's what you have to understand. And everything, how the kernel is doing, because of every operation, whatever you're doing, I'm doing a double click here onto the Google Chrome. What it is doing, what is happening here? A process is getting created, sir. Okay, fine. Oh, a user is actually double clicking on some folder. Oh, the folder is getting open. How the folder is getting open? A process is getting created. For every operation, what the user is doing, a process is actually getting created. This process will finally get executed by your kernel. And what are the output you needed? That will be provided for that particular user. That's how it happens. So in the Linux system or in Windows system, everything is not, it's a process only, right? Everything is a process, right? See here, if you execute the task manager, you execute task manager, see, you go to the details, see, these are all the processes are running now, sir. See, how these processes are running, these are all our processes which are being created. So each and every process is doing some task actually. And every process has a PID, process identification number. PID calls a process, it has some number actually. The same thing, whatever I'm launching the task manager, here in Linux, we can execute with the command ps-ef, right? So ps-ef command, which will show you all the process which are running in your system. See, these are all the processes that are running. Of course, here also you have a PID, see PID, process identification number we have. Like that. Anyhow, we'll come to across to this later on. Right now, I'm just saying that. So how exactly the process, so that's how it is. Okay. Coming back to here. Sorry, sir, we are tangentially, we are going somewhere else, but we'll get back to our topic actually. This you understood, right? These are the three data channels you understood, right? And how to use this, you have understood it. Okay. Whereas, right? So how to make use of it, we know. We are missing one more thing here out of this is double less than sign. Double less than sign, we call it as a here operator. Oh, what is a here operator? Here operator is nothing but you take a lot of input from the user and show everything as an output. Like for example, suppose, sir, whenever I want to sort any file, right? I want to sort any file. Suppose I have an Alice file. Inside the Alice file, I will have some character like this: banana, orange, apple, grape, and something. I have this 4-5 lines are there, and I'll change this. I want to sort the content of the file Alice. So I'll just sort Alice. It will sort in an alphabetical order. Now, I want to use a here operator, this operator, double less than, along with the sort. How to do it? I'll just sort, double less than, specify some delimiter word, like something, EOF, something. I can even put as a Raj also, anything, Rajesh, Mahesh, anything. Okay, but I'll just say EOF, end of file. So I'll enter. See, it takes me to the secondary prompt. So here I'll give banana, orange, grape, apple, right? Once you give the complete input, right, you have to specify this delimiter word at the end. See, it has sorted in an alphabetic order. So what the here operator is doing here, take maximum input, take all the input from the user, and finally give an output like that. That is how here operator is used. This is heavily used in lot of scripting, sir. In our office also, I have written a lot of scripts. I am using the here operator heavily at my work actually. The use case I will explain you when I am explaining the scripting, right? I will tell you there you will actually appreciate that how exactly we're using here operator. Okay. Like that.
Rajesh, don't mind, can you repeat this again?
Sir, what I'm doing a here operator will take all the input from the user, okay, and then appropriately it will give the output based on what you have mentioned over here.
Okay.
Right. For example, he double less than Raj. Hi, how are you? Bye. And mention the same Raj at the end. See? Oh, here it is not showing, but it will show. It will take all this input and show as an output. So here, what you have to do, cat double less than like this. Whatever the input you gave, the same output you are getting actually. Take all the inputs and give the output to you at one shot at a time. So that's the reason you are using here operator. Yeah. Yes, sir. But you have to mention the delimiter word. Here, this is the delimiter word. This is drain mode. You can give any name. It doesn't matter. Okay. Okay. Any doubts you have, sir? Guys. No doubts. Sir, full. You got exhausted. You have energy to hear again or exhausted?
Yes, we can stop here and we can continue next class.
Okay, so here we have just stopped over here. What we have to do now? See, I have come to here, but actually we have tangibly go. We have to go on the backside. Where we came? We came from the pipe file, right? From the pipe file, I came over here to explain you about what is the redirection operator, all these things. Now in the next class, I have to start from the pipe itself. So here itself, it has some more concepts. I'll be explaining this, right? So next session we'll start with the pipe. Correct, guys?
Sure, Rajesh.
Okay, guys, chalo then. And I think some of you can stop the recording.
Yeah, let me do.
Any one should stop, not all. Not all. Some people will stop and it will go for recording something. If Ashish, if you're not able to stop, somebody else can stop it. Naresh, can you stop it?
Yes,
Yeah,
sir.
available.
But it not.
Okay. Let me check.
You check it.
Let me stop, Rajesh.
Yeah, yeah.